Welcome to the deep dive. Today, we are looking at something pretty revolutionary. It's this idea that has kind of been floating around for a while, in self-help and that sort of thing.
Right.
But now, hard science is actually testing it. The idea that a creative experience, a systematic one, can actually delay how your brain ages.
Biologically, yeah.
Okay, so let's really unpack this. We're not just talking about, feeling a bit sharper. We're talking about something you can actually measure. A physical protection against your brain declining with age.
Mm-hmm.
The source material for our deep dive today is, well, it's a massive piece of research. I mean, they took data from over 1,400 people.
It's a huge data set.
And they combined that with some really advanced machine learning and neuroimaging to see if creativity gives you a health benefit that you can literally put a number on.
And that's really the landmark piece here because, like you said, for years, the benefits of, picking up a guitar or learning to paint, it's all been anecdotal.
Sure. Or just based on simple cognitive tests.
Exactly. This study goes way beyond that. It uses this really precise biomarker they call the brain clock.
A brain clock. Okay. That sounds like something out of science fiction. How does that even work? Why is that better than just, an IQ test?
Well, it's a prediction model. It uses neuroimaging, specifically something called ME functional connectivity.
So it's mapping how the brain is talking to itself.
Perfectly put. It maps how different regions communicate, and from that, it predicts your brain's biological age. The more efficient the network, the younger the prediction.
I see.
And that leads to the key metric here, which is the brain age gap, or BAG.
So the BAG. That's the difference between my age on my driver's license.
Your chronological age, right.
And the age this model thinks my brain is based on how it's performing.
Precisely. And that gap, that BAG, it tells us so much. If your BAG is positive, so your brain age is predicted to be older than you actually are, that points to accelerated aging.
And that's not good.
No. We see that positive BAG in almost every major neurological and psychiatric disorder. It suggests there's a vulnerability, a breakdown in that network efficiency.
Which means the whole mission of this deep dive, the core hypothesis, is to see if these creative activities can actually push that gap into the negative.
Can they make your brain functionally younger than your body? Can they show delayed aging?
That's the question.
It is. And, before we even get to the results, which are amazing, one of the most interesting parts is how they defined creative.
Right, because that's the real pivot. When you hear creativity, you think of, a painter or a musician. And study one, the big expertise study, definitely included those. They had professional tango dancers, musicians, both instrumentalists and singers, and visual artists.
Skills that take years and years of practice.
Exactly. But this is where it gets really fascinating and it kind of challenges your assumptions. The fourth group they studied, video game players. Specifically, expert players of the strategy game StarCraft 2.
Yes. And including them is so critical here. It really broadens the definition of creativity they were working with.
So it's not just about art.
No, it's about the ability to produce ideas or solutions that are both novel and effective. In StarCraft 2, you are constantly making these tiny adjustments. You're developing unique tactics. You're adapting in real time under incredible pressure.
So that kind of systematic mental work, that qualifies as high-level creativity just as much as writing a song.
It's creativity materialized as tactics. Absolutely. Yeah. It's the process of complex, personalized problem solving.
I have to say, it's still a bit of a surprise to see a competitive video game right alongside professional tango dancers.
But that's what makes the overall result so powerful. Because when they pool all the data dancers, artists, musicians, gamers, the finding was just, overwhelming. It was completely domain independent.
What do they find?
That these systematic creative experiences are strongly associated with delayed biological brain aging.
And the numbers here are they're staggering. They compared these experts to non-experts of the same age and the creative experts. Their brains were, on average, negative 5.50 years younger than their calendar age.
5.5 years. Just think about what that means. If a positive BAG suggests vulnerability to disease, a negative BAG of that size, it points to a powerful protective effect.
A prophylactic almost.
Yes. These activities are literally changing the brain's architecture to resist the normal wear and tear of aging.
Okay, let's break down those domains, because while they were all strong, there was a bit of a hierarchy. The tango dancers, their results were just wild.
They were. Tango is so complex. You have motor control, memory, social synchronization, improvisation.
All at once.
All at once. And that translated to the biggest reduction in brain age. Tango dancers were, on average, 7.1 years younger.
Wow. Over 7 years. That is a huge return on your investment in learning a skill.
It's incredible. Visual artists were next. They came in at a delay of -6.2 years.
Still amazing.
Then musicians, with all that auditory processing and fine motor skill, they saw a delay of -5.4 years.
And our StarCraft II experts, the gamers.
Even they, with their creativity being purely strategic, showed a really robust delay of -4.1 years.
So what this is really showing is the inverted pattern of what we see in disease. It's a profound protective effect, and it comes from this sustained, challenging, creative work.
Which then brings up the next obvious question, right? Do you have to be a lifelong professional to get this benefit?
Yes, that's the key question for anyone listening. Can I start now and get some of that benefit? Is it scalable?
And Study 1 actually looked at that.
They did. They found a significant negative correlation between expertise scores, so how many years you practice, how many hours a week you put in, and the brain age gap.
So, in plain English,
the more skilled you are, the more committed you are, the bigger the delay in your brain's age. It literally pays to stick with it.
So long-term dedication definitely builds a stronger defense, but the researchers didn't stop there. That expertise study, it shows a correlation over a lifetime. They wanted to see if they could actually cause a change in real time.
An intervention study.
Exactly. Which brings us to Study 2. This was a pre-post learning study with non-experts.
Okay, and for this short-term concentrated training, what did they pick?
They went back to StarCraft 2. They took a group of total non-experts and put them through just 30 hours of intensive training.
30 hours, okay.
The results were, frankly, astounding. After just 30 hours, these non-experts showed a significant brain age delay of -3.06 years compared to where they started.
Wait, hold on. 3 years of biological age knocked off from 30 hours of focused work. We need to just sit with that. That completely changes how you think about your free time. That makes learning a new skill feel like, preventative medicine.
It really does. And the effect was very specific. They had an active control group play another strategy game, Hearthstone, for the same amount of time. Hearthstone is more turn-based, less about that rapid, spontaneous adaptation. That group showed no change at all in their brain age gaps.
So it's not just playing a game. It's the kind of complex, real-time, creative thinking that StarCraft II demands.
That seems to be the active ingredient.
But okay, how do we know this isn't just because they were, focused on something? Did this brain age delay actually link up with them getting better at the game?
Vital question. And yes, it did. The reduction in the brain age gap was strongly correlated with their actual performance improving in the game.
How do they measure that?
Specifically, with an increase in their actions per minute, or APM.
Right, APM. That's how many clicks and commands you can execute in a minute under pressure.
It's a great proxy for speed and tactical efficiency. And the correlation was strong, R equals nadish 0.508. The people whose brains got functionally younger also got functionally better at this very complex task. The biological benefit and the behavioral benefit were just two sides of the same coin.
Okay, that's the measurable behavior. But now for the biggest question of all, the how. Mechanistically, how is moving your fingers faster on a keyboard or learning a dance step? How is that changing the actual biology of your brain? What's going on inside the network?
This is where we get into the real neurobiology.
Yeah.
The researchers used some advanced analysis to pinpoint where the changes were happening. And what's so fascinating is that the delayed aging wasn't just, spread evenly across the brain.
It was targeted.
It was primarily observed in the frontoparietal hubs.
And why are those regions so important?
Because your frontal and parietal regions are basically command and control. They handle executive functions, attention, problem solving. But crucially, they're also the network's most vulnerable to aging.
So these are the areas that tend to decline first.
Exactly. They're frequently the source of those positive bags we see in disease. So these creative experiences are acting almost like a targeted workout for the weakest, most age-vulnerable parts of the brain network.
So let's translate this. The study found that these lower bags, this delayed aging, was tied to more efficient brain networks. How does that, what does efficiency mean here?
Well, we can break it down. They found an increase in local efficiency. So think of the brain areas dedicated to a skill like the motor cortex for the dancer communicating faster and better within their own little local cluster.
So that specific department is running much more smoothly.
Precisely. Information processing for that skill gets quicker, sharper. And they saw that improvement in both the long-term experts and the short-term learners.
But the experts, the ones with a lifetime of practice, they showed an even deeper change, right?
Oh, yeah. They also showed increases in global efficiency and global coupling.
Yep.
Global efficiency is about the communication across the entire brain. The whole corporate structure gets better. And global coupling, which is the deepest change, is about the actual physical strength of the connections.
So years of practice literally strengthens the hardware of the brain.
It makes the whole network more robust, more resilient to the systemic effects of aging.
That's such a powerful distinction. You get local improvements quickly, but that long-term commitment, it changes the whole architecture.
It does.
And if we map the cognitive processes onto these changes, what skills were being optimized?
Well, for the long-term experts, the enhanced regions mapped perfectly to their crafts. Motor control, rhythm, coordination, visual salience, everything a dancer or artist needs.
And for the short-term StarCraft learners?
For them, it was almost all related to attention. Visual perception, object recognition, sustained visual focus. It perfectly reflects the high-demand learning environment they were in for those 30 hours.
So the evidence just keeps lining up.
Yeah.
These challenging, systematic, creative experiences, whether it's over a lifetime or in a short, intense burst, are tied to real, quantifiable biological benefits.
They are literally slowing down the functional aging of the brain by strengthening its most vulnerable networks.
And the real-world implications of this are just massive.
Oh, huge. I mean, these are objective biological findings. This gives real medical and political weight to things like social prescription.
Where a doctor might actually prescribe learning an instrument or joining a dance class.
Instead of just relying on pharmaceuticals, it supports this whole push for creativity-based interventions to improve brain health and well-being.
It really reframes how we should all be thinking about our hobbies. They aren't just for fun, they're a form of high-return biological maintenance.
They're a measurable form of resistance against how time affects our most critical organ.
So, for everyone listening, what does this all mean for you? We've learned that dedicating yourself to a complex, creative skill could delay your brain age by more than 7 years. And maybe even crazier, that just 30 hours of systematic learning in a challenging new field can knock off 3 years.
It's a powerful thought.
It is. So given that even something as unexpected as a strategy video game showed this effect, what new, challenging, and novel activity could you pick up this week that might just start winding back your own brain clock? Maybe think less about pure relaxation and more about robust, creative resistance.